Hello. Hi, everyone. So I want everyone to raise their hands. Everyone raise your hands right now and give yourself a pat on the back because it is your last session. Congratulations for making it through. Hi, everyone. I'm Alice. I'm a developer relations engineer working on background work and foreground services. Very spicy topic. So imagine this. You're a developer wrapping up a major app release, and there's only one last feature you need to implement, making sure your feature continues in the background. You go to the documentation and you're like, huh? There are so many ways to do this, so many nuances. What's the right solution? You're left wondering, why is figuring out how to continue an action after the user has left the app so challenging? The main methods that developers know of today of continuing action in the background has evolved into two general purpose APIs, the Jetpack Library Work Manager and the Platform API Foreground Service. However, building an application is nuanced, and oftentimes a general definition isn't enough to understand how to implement the APIs to your specific use case. Also, these APIs have changed a lot over the past few releases. So we'll go over some of these new changes in Android 14 and also the various nuances to better understand what solution you should actually be using. The other reason why these APIs are challenging to work with is because they directly impact battery life. The Android ecosystem has the difficult job of balancing the needs of device manufacturers, developers, and users. And this has caused Android to make some difficult trade-offs, some of which involve adding additional platform enforcement to make sure that the platform is more resilient to power training APIs. Behind the scenes, we're also collaborating with manufacturers to make sure we're aligned on API definitions so the ecosystem is more consistent for developers and less worried about device manufacturer inconsistencies. More on that later. So if background work and foreground services are confusing to you, you're in the right talk. We're going to go over the following topics. What is asynchronous work, background work, and foreground services, and what are their common misconceptions? What is new with foreground services in Android 14? How do I decide what API to use in Android 14? And we'll have a quick quiz to test your knowledge. And finally, we'll end it off with what the future looks like for these APIs. So what are the differences between asynchronous, background work, and foreground services? There is a lot of misconceptions around these topics and also confusion, so let's dig into it. Before we really understand what APIs to use, we need to make sure we're aligned on our definitions. So what is a background work, asynchronous, and foreground services? Here's a simplified decision tree to help you understand. We'll first start with a question: what action is needed in order to run the application after it's been backgrounded? If it needs to continue work once the application has been backgrounded. If it doesn't, then you can use asynchronous work. If it does, and it needs, you can ask the second question: should the work be invisible to the user, and can the work be retried or resumed at a later time? If not, it's most likely foreground services or the alternative APIs that I'll cover later. And finally, if it can be invisible and resumed, then it's background work. Again, this is a very simplified diagram. We're going to go over the nuance later. So running in the background is a bit of a loaded term, and one way to confuse it is to reference it as doing work outside of the UI or main thread. While it's important for developers to understand that intensive work should not be run on the main thread, it is also important to note that asynchronous work is not the same as continue work in the background. This means that if you're using a coroutine or a Java thread, this will not persist after the user has left the application. Another common misconception is to assume that platform APIs, including services, job scheduler, intent receivers, support mechanisms that will automatically run asynchronously. It's really important to ensure that you wrap this work in an asynchronous call so that it does not run on the main thread. Whenever possible, it is recommended to use the Jetpack solution Work Manager, as the library can support asynchronous work through coroutines and callback listeners. Speaking again of loaded terms, we come to this concept of background work. Android's definition is that an app is running in the background when it satisfies the following conditions. None of the app's activities are currently visible to the user, and also the app isn't running any foreground services. Work is commonly invisible to the user, and it doesn't need to run in a deterministic manner. This type of work is usually associated with the Jetpack Library Work Manager. Background work can also refer to the platform API, job scheduler. This is an API that allows the system to decide when to run work at optimal times. And you'll hear us interchangeably using jobs and work, which refers to jobs as meaning the system API, whereas work is the library above it using the system APIs. But wait, some of you may be hesitant around using Work Manager because you heard this thing called quotas. So let's shed light on this topic. Standby quotas and standby buckets and quotas are two tools that the Android system uses to ensure fairness in resource consumption. A standby bucket is used to determine what applications get more runtime quota. They can also impact whether or not jobs have access to network. The system dynamically places your application into different buckets based on a number of factors, including if the application is used more often, used more recently, or might be misbehaving. Also note that manufacturers might be able to set their criteria for different ways that non-active apps might be assigned to these buckets. So it's really important that you don't try to manipulate your app to be in a specific bucket. Quotas are also the maximum duration that a job can run in a 24-hour period. And you can view more information on how quotas are impacted in the developer documentation. Another thing to note is that starting in Android 13, high-priority FCMs will no longer be impacted by app standby buckets. One common misinterpretation for developers who use foreground service instead of Work Manager is due to concerns around job quotas. And this is an incorrect usage of foreground service. Later, we'll go over appropriate scenarios to use foreground service. So ambiguity can feel uncomfortable to account for, so here are some actionable advice. While there are a number of standby buckets that your application can be put in, the most important one is to test the restricted standby bucket. So make sure you trigger your application into this standby bucket to understand how are the impacts. Rather than considering foreground service, use the set expedited flag for your workers, so you can say that they should be executed as soon as possible. And although work can run in a non-deterministic manner, Work Manager ensures the ability to retry the work at a later time. Ensure that you consider the scenario when designing your workers. So let's go into depth a little bit more. In order to test your application standby buckets, you can figure out what standby bucket the app is in using the first command, and the second command puts your application into the restricted standby bucket. Secondly, in situations where it's really important for the work to run as soon as possible, use a set expedited work request. It's just a single flag to make sure that it says, hey, run me as soon as possible. And finally, when you use Work Manager, it has automatic support to retry the work at a later time. So if the work does not run to completion initially, the system will automatically schedule the work to retry at an appropriate time. This means that this entire function will run again. So whenever possible, you should restore the state at the beginning of your worker. And another tip is to ensure that all scenarios consider failure states. So when there is a failure state, return result failure. Otherwise, the worker may run longer than you anticipate and drain more battery. Lastly, we have foreground services. Foreground services are intended for the in-between state where an application is no longer in the foreground, but the user still expects it to keep running. They usually have some sort of UI in the form of a notification to share the state and allow the user to control the action. This should be a scenario where it would be really detrimental to the user experience if the system were to defer the action to a later time. Here's a couple scenarios of valid foreground service usage: syncing to a Bluetooth device, playing music from the background, or sharing your location for navigation purposes. Starting in Android 12, as many of you might know, foreground services must start in the foreground and allow you to continue the action even if your app is backgrounded by the user. It cannot start, in most scenarios, in the background. We realize that this naming convention can be a little bit confusing to say. You're starting a foreground service, but somehow it continues running in the background. It makes it sound like it's background work. It is not. This is because a foreground service elevates the process state. So there are additional privileges that this process has, including access to while in use permissions like microphone. Foreground services can also be created with Work Manager using the set foreground method. This is also an area of confusion, as historically it's been named long-running worker. It's important to note that it is a valid way to create a foreground service in a manner, but it means that all platform enforcements, including the requirement that it must start from the foreground, applies to this way of creating foreground services, as well as all the additional platform enforcements that I'll mention later. Another common misconception is to confuse background service with the same capabilities as foreground service. Again, confusing, I know, to ensure that this work continues in the background. So to ensure consistency across all OEMs, you should be using an API intended for continuing work. So that is foreground services or work manager or some of the other ones that I'll mention later. So now that we have a clear understanding of the differences between asynchronous, background work, and foreground services, let's recap the common misconceptions around these APIs. So asynchronous work, asynchronous APIs or a service with no foreground service declaration will not ensure that action continues running in the background. With that said, when you're using platform APIs such as foreground service, make sure that you're running the work asynchronously. Quotas are not a valid reason to use a foreground service instead of Work Manager. Instead, use Work Manager and test standby buckets, use the set expedited flag, and add resume logic. And finally, foreground service is not background work. It's meant to continue a user action, so use it only in scenarios where it would be detrimental to the user experience if the system were to defer the action. So, as mentioned, Android is continuously understanding the nuances between all these platform APIs. And something to note is that there is a big change coming with Android 14 with respect to foreground services. In Android 14, we're introducing mandatory foreground service types. If your app targets Android 14, it must specify a foreground service type or types in the Android manifest. This is important to note that it is a breaking change, so if you don't add these types, your application will crash at runtime, and this applies to libraries as well. As you can see here, most of these foreground services actually already existed prior to Android 14, and some of them were actually already a requirement. Most of these types are use case specific types, with scenarios that within Android we commonly understand are scenarios that require a foreground service. We want to ensure that all valid foreground service scenarios has been introduced. So we also introduced two use case specific types, health and remote messaging. You can read all about these types in the documentation linked on the bottom. We have also introduced some special types in Android 14 that are not use case specific. Short service is meant for finishing critical work that cannot be interrupted or postponed, and it can only take up to 3 minutes. An example of this is saving data to a disk or finishing a payment. This does not require additional foreground service permissions and does not also require justification in the Play console, which we'll get to later, but the process will ANR if you do not call stop foreground within 3 minutes. System exempted is for system applications and integrations, and special use are for other foreground service use cases that are valid and have no other matching types. Note that this type will require you to specify your reasoning for usage. So you might be wondering, wow, this feels like a lot of work. How exactly does this benefit me? Well, these types help developers better understand in which scenarios it is valid to use foreground service, which has been a common source of confusion in the past. Foreground service hasn't been the easiest to figure out how to use correctly, so these additional platform enforcement and platform enforcement are to ensure that developers aren't intentionally or unintentionally misusing foreground service. And finally, these foreground service types were a necessity to ensure consistency across manufacturers. With the introduction of foreground service types, play policy, and various other changes to the Android platform, we've been able to align with device manufacturers, including Samsung, on a consistent experience when using foreground service, which has not always been the case in the past. As mentioned in their developer documentation, foreground services in Android 14 will be guaranteed to work. And this is a really huge win in our efforts to ensure API consistency across devices. All right, so let's get into the nitty-gritty. What is the necessary things to require that are necessary to declare a type? Here's the 3 steps. First, declare the foreground service in the manifest, the permissions in the manifest, then declare the foreground service type in the service declaration in the manifest, and finally, ensure any platform enforcements are valid before calling start foreground. Let's go through an example. In this scenario, I'm building a fitness app, and we're tracking both my health stats and location tracking to report how far I ran. So if I look at the developer documentation, I will need to identify the types and then permissions necessary to declare. Because this is a health app, I'm looking at the documentation, and it says that I need to declare the health type as well as the health permission in my manifest. And I also require location tracking, which means that I need to declare the location type and the location permission in my manifest. Here is a snippet of my manifest declaration. So we can see that we already have the foreground service declaration. Now we have to add the health declaration and location declaration. When we declare the service, we will need to specify the foreground service type to be health and location. This means that the foreground service can be started as any combination of these types, and if I specify this programmatically, I can choose any combination, or if I don't specify it, it will default to the manifest declaration. So now that we've declared the manifest definitions, let's ensure that we fulfill any platform requirements on these foreground service types. We can do this by looking at the same documentation. We are declaring these 2 types, which have different runtime permissions. So for the health permission, we can use any of the 3 permissions listed as specified in the prerequisites. In this scenario, I'm going to use activity recognition as part of my requirement. And for the location permission, there are either 2 of these permissions, but as a location-specific use case, I would have to declare both of these and ask the user to pick one. So if I'm coming from an existing app, I likely already have these permissions declared, but let's just show them being added. I'm adding the activity recognition and also the course and find permission. So our final step involves ensuring that these permissions are granted before starting the foreground service. In this particular case, both health and location foreground service platform requirements are runtime permissions. So prior to calling foreground service, I need to check whether or not I already have access, whether or not the users already have access to this permission. If not, I should show some sort of dialogue to request the user to grant the permissions, or if that's not possible, show some sort of error message. Final thing, at the time you call start foreground, you can choose to start a foreground service type that is a subset of the manifest types declared. So suppose the user only granted location, that's okay. I can start a foreground service with just location, or I can start a foreground service that has both location and health types defined. So let's quickly go over how this differs if you're using the Work Manager provided set foreground API. So Work Manager declares a foreground service on your behalf. So thus, there is only a single foreground service declaration. And if you're using the set foreground service APIs, all of these type declarations need to go through the system foreground service that Work Manager declares on your behalf. The manifest merger tool combines the service elements that you've declared and Work Manager has declared, and it will combine them into a single one. Here is what the custom worker definition looks like. This is using a coroutine worker. So before you do any kind of work, you should make sure that the permissions are granted again before calling set foreground. And then when you create the foreground info, you will need to pass through the location and health foreground service type. So foreground services are not only being enforced in the platform side, we're also adding a new declaration page in the app content page in Play Console. So this is actually very new. It just actually got launched like several days ago. So let me just quickly go over what this means. This will not be required until next year sometime, TBD on timeline. So in order to do this, once you have declared a foreground service, we will parse through the manifest and check to see exactly what permissions you're using. So for every single type, we're going to ask you to define the description of the app. We're going to ask you to determine the user impact of not being able to be deferred or interrupted by the system. We're going to ask you to include a video demonstrating the foreground service feature, and also choose one of your use cases from a specific list. You can also select other. Again, this is not yet mandatory. You can check it out in your Play console, but it will be sometime next year. So one final thing that is also really important. Remember how I talked about alternative solutions to foreground service at the beginning of this talk? Well, sometimes a foreground service is not the most ideal solution to managing your use case. Why aren't they ideal? They're not cognizant of your use case. A foreground service is basically a blank canvas. You can manage everything yourself, and it can be quite complex. You're responsible for managing the lifecycle of the foreground service, and you also have to know all these various exemptions if you're using them. So you might end up using more battery than necessary. So we've introduced a list of alternative APIs in the foreground service type documentation that has references to which APIs you can use instead. And some of these APIs have actually existed for a while, and they've had lifecycle awareness, but you just didn't know because they weren't really visible and discoverable. So this documentation that we share will list the type and the alternatives that you can use. These APIs also reduce the complexity of the integration by integrating the lifecycle of the intended action within these APIs. So some of these examples include Companion Device Manager, which offers API for searching and pairing, user-initiated transfer. This is an API introduced in Android 14, and it is only available as a platform API, but we're working on a Jetpack library and it's coming soon. And there's also a telecom library for VoIP and calling. So you can view all of the alternative APIs in the page listed in the bottom right. Here's an example of an alternative documentation and what it looks like. So this is for the data sync foreground service. Note in this blurb, it also says, hey, this might be deprecated in the future. So it's important that you look through the alternatives especially. Why is data sync being deprecated? Well, we're introducing more alternative solutions, such as user-initiated data transfer, that are better suited for the scenarios that they're meant for. For this particular scenario, we're doing user transfer of content and might take long periods of time, and we recognize that Work Manager hasn't been the best solution for this type of work, but now we have something that does run for a long period of time and also has the ability to do constraint matching for network transfer. Overall, we anticipate that creating these alternative APIs with lifecycle awareness will offer a better developer experience than the one that currently exists. So let's do a quick recap of foreground service changes. Foreground service types. Declaration is now mandatory in the manifest in Android 14. This is a breaking change. Coming soon, you'll also be required to declare foreground service usage reasoning in the Play console. And finally, even in situations where you can use a foreground service, they might not be the ideal scenario. So we created a section in documentation for you to explore alternative APIs. So we're more than halfway through now, and while we've clarified a lot of APIs, you're probably thinking, Alice, just tell me what to use. So let's do that. These are the 3 things to consider when you're continuing doing work in the background. So the first and easiest way to understand how to do running in the background is to look at the relevant APIs you're using. Secondly, consider what mechanism the action is triggered, particularly if it's coming from the background. And finally, if triggered from user action, consider the characteristics of the action. So let's elaborate on this more. What do I mean by looking at relevant documentation? So as mentioned before, doing something in the background is a general thing, and it's often associated with foreground service with Work Manager, but it might not always be the best solution. So many documentation many dedicated APIs have documentation that talk about the best practices for running in the background. In this particular example, I'm running a widget, and I want to update this widget periodically. So if I'm looking at this documentation, I can see that there is actually a dedicated API to update the widget periodically. There's also another portion that talks about how you can instead use Work Manager to update the widget periodically if you need it to happen more than 30 minutes. Again, these are ways that the relevant APIs have offered to better describe how to use this, and I would definitely try to look for this documentation first before resorting to the next steps that I'm going to talk about. So in the cases where this information isn't apparent, or maybe you're not using a dedicated API, consider this second tip. So what is the action, or what is the mechanism that you're trying to use to trigger the action? So if you're starting the work from the background, you likely have one of these 4 options for triggering some sort of work from the background. You're using a broadcast receiver, you're using Firebase messaging, you're using alarms, or you're using a bound service. You can also schedule work from the foreground that will happen in the background, but I kind of consider that user-initiated. So let's talk about these 4 situations. So for most of these situations that are background triggered, guess what? You should be using Work Manager. So you can do this within the callback of these methods. A couple callouts. It is possible to use go async within the broadcast receiver on the onReceive callback to extend the runtime of this broadcast receiver by 1 minute. Also note that this is a system API, and like I said before, it doesn't automatically run asynchronously, so make sure you're wrapping this in a coroutine. The second callout is that with bound services, a service that is bound to another service in the foreground will have similar privileges as that service. So it is possible to start a foreground service or Work Manager when it is bound. All right, so just to make this even more confusing, as always, there are exceptions to the rules. So with foreground services that are, remember foreground services are meant for user-initiated action, but not always. So we're going to give a couple examples of scenarios where it might not be for user-initiated action. So we have some broadcasts that may allow you to start foreground services from the background. For high-priority FCMs, there might be some scenario where, say, you're starting a phone call with another user, or you're doing location sharing that really needs that immediacy. So we've offered this as an exception. For alarms, there are exact alarms, like you want to schedule an alarm to play music in sometime in the future, and this needs some immediacy and guarantee of determinism. So we allow this to start a foreground service. And finally, there are also use case-specific APIs. So there are a number of these APIs, such as activity recognition, geofencing APIs, or companion device manager, that are able to start from the background and start a foreground service. All of these exemptions are, again, documented on DAC. All right, so finally, we have the user-initiated scenario. So hopefully these questions will be actually a repeat of things that we've learned, but just for your help, I've broken it down into 5 various questions that you can ask yourself when you're doing a user-initiated action to figure out what API to use. So the first, actually, I'll go over in the next steps, so I'm going to break this down for you. You're welcome to kind of read through this. But hopefully, again, you understand this already because I've already covered it. So first question, does the action need to happen immediately? Well, if it doesn't happen immediately, then this work is deferrable. You should use Work Manager. Secondly, is the work short duration and intended to wrap up a critical action? So if yes, this is one of the few scenarios where it is okay to use a foreground service without justification. You can use the short service type. I also want to mention that there's been some confusion around expedited workers versus short service. In some situations, it's really not feasible for work to be deferred So we recommend using short service instead of expedited workers in these scenarios, such as payments. The third question is this feature relevant to the core functionality of the app? So if it isn't relevant to the core functionality of the app, perhaps you really don't need this to work in the background, so perhaps you can just design it to not work in the background. Fourth, will interrupting the action cause a negative user experience or cause a user to see this as not working? Again, this is something that Work Manager is much better capable of handling, and it has all of these various mechanisms to retry the action at a later time, so redesigned to use Work Manager. And finally, does there exist an alternative API to foreground service that meets your needs? So if there is, then you can use alternative API, and if not, use foreground service with the associated type. All right, so that was basically everything in the talk, so we're gonna do a very quick quiz to put our knowledge to the test. Hopefully y'all been listening, no worries if not. So the first question, and these are all just features that, let's say a PM comes to you and wants to design. So the first question is, the feature involves the ability for the user to click a button to download content to the device, and they'll see a notification with the download progress. So we have three options here. We have foreground service and use a data sync type. We have Work Manager, or we have this alternative API called user-initiated transfer. Yeah, just shout it out at this point. Who wants to, three? Okay, I've heard from some people are listening. That's a great, great thing. So there are several keywords that give away this answer. This is user-initiated. It needs to show up a notification. So the final thing that we have to check is to see whether or not there does exist an alternative API for this scenario, and there does. So we would use user-initiated in this scenario. The second question is, the feature involves the ability for the application to silently sync content whenever a broadcast happens. So we're gonna have three options. We're gonna use the short service type, we're gonna use Work Manager, or you can run the work in a broadcast callback. Shout out your answers. Okay, cool, yeah. The answer is 2. So there's a few callouts here. One is the keyword silently, which means we don't want to show a notification. Secondly, this content is being triggered through a broadcast. So a broadcast cannot trigger a foreground service generally, and it's coming from a background scenario. And so the other two options is to run the work in the broadcast callback, which might not have enough time for you to complete, or you can use Work Manager to schedule the work to completion. And another thing to note is that you could use an expedited flag here to run the work with more immediacy. Third question, this feature involves the ability for the user to click a button to send payment, and this action is critical and short duration. Great job. So yes, the answer is number 1. So a few more keywords. This is a critical and short duration action. It's sending a payment. You're clicking on a button. So again, in this scenario, you won't want to use Work Manager because it could defer this action to a later time, and you don't want to have a payment happen 10 minutes later. So use short service type. So that is everything for my talk. So let's quickly go over what the future holds for these APIs. So what does the future hold? We're going to introduce more alternatives to foreground service embedded in the APIs that you already use. This means a reduction in complexity in terms of integration instead of using foreground service types. There are also some niche scenarios where foreground service might not be the most user-friendly situation and have various exceptions. So you can instead use this alternative API instead. And I saw some faces in the audience, so if you have any feedback for this, I actually have a survey at the end for you to give feedback. The second thing is that we're going to be collaborating with more manufacturers around ensuring these APIs are consistent across all manufacturers. And finally, we're going to be introducing more platform enforcements and developer education to avoid misuse of power-draining APIs. We understand that figuring out when to use these APIs aren't always obvious, and it's not always obvious what the right way to do it is. So we'll be adding more documentation around this. And that was a lot, so I'm going to do a very quick recap. So first, we learned about asynchronous background work and foreground services. They're not the same thing. Asynchronous APIs and background service will not ensure that the action continues running in the foreground. Also, quotas are not a valid reason to use foreground service instead of work manager. Secondly, we learned about all the various changes happening with foreground service. It's mandatory targeting Android 14. You have to add some play console reasoning. And finally, we added a section for you to discover alternative APIs. And third, we learned about the ways to understand APIs in terms of continuing action. So one is looking at the relevant documentation. Second is understanding what mechanism the action is triggered by. And finally, for user action, consider the characteristics of that user action. So that's everything. And we're looking for feedback. Just wanted to mention that this talk actually isn't, it's ahead of the documentation currently available on androiddeveloper.com. So if you have feedback around this talk or whether or not it was useful for you, this would be the best time to give it as we're updating the documentation right now. Again, you're welcome to send me any questions, emails around questions, and I'll be right here if you want to ask me any questions after the talk. Thank you.